in terms of major contributors, that's when we determine, okay, which of these is the one that looks the most like the hybrid? Is it number 1 or is it number 2? Okay? And to figure that part out, we have to use just a few rules. Okay? So often it turns out that one of the resonance structures will be more stable. Okay? So it turns out, let's say you have more than one resonance structure, one of them is the most stable. So that's going to be the one that we use. And that means that it's going to contribute to the hybrid more than the others will. Okay? And major contributors will often have the following characteristics. Okay? So the first thing is that neutral structures are almost always going to be more stable than charged ones. Okay? So if I have a choice between, let's say I have a resonance structure that's neutral and a resonance structure that has charges on it, I'm going to pick the neutral one to be my major contributor and to be the one that looks most like the resonance hybrid. Why? Because that's the one that's overall most stable. Okay? So even if the other one is possible, it may exist to some extent, but the one that's really going to exist in excess, or not exist, but the one that's going to contribute in excess is going to be the neutral one. Does that make sense? Cool. So a good example for that would be where I showed you guys the neutral heteroatom example on the other page, where there was one that had basically a neutral structure and then one that had a positive and a negative. The major contributor would be the one that was just fully neutral. The one that had a positive and a negative would be a minor contributor because that one already has charges. It's not as stable. Okay? So let's keep looking at this. Another rule is that if possible, every atom should fill its octet. So what that means is that we're going to look towards resonance structures that are not satisfying the octet. Let's say ones that have too few electrons. Those are usually going to be minor contributors. If I have a choice between a resonance structure that fulfills all of its octets and one that doesn't, I'm always going to pick the one that does fulfill its octets. And then finally, the electronegativity trends are going to determine the best placement of charges. Now, I know it's been a really long time since you talked about electronegativity. In fact, for a lot of you guys, you haven't heard about it since Gen Chem. Okay? So I just want to remind you guys that this is the electronegativity scale. What it basically says is that as you go to the right and as you go up, your electronegativity gets higher. What that means is that fluorine is the atom that is most comfortable having a negative charge or having electrons on it. So if I were to pick that the negative charge is on a fluorine or the negative charge is on a carbon, which one is going to be more stable? What do you guys think? The fluorine, right? Because that's electronegative. That means that it likes to have electrons or negative charges on it. Whereas carbon is not as to the right as fluorine, so carbon is going to be a lot less comfortable having that negative charge. Does that make sense?